Okay, so the point of the talk is kind of in four steps. The middle ones will be a bit longer than the end ones. Beginning just to explain a little bit why we might resort to emergence. Father Thomas did me the favor of giving you a little background on that, but I'll just give you a little more. Then some difficulties with emergence, some problems that accounts of emergence face, as characterized by Jessica Wilson, teaches at the University of Toronto. Then showing how Lonergan's interpretation of Aquinas can create kind of an escape valve that allows us to have emergence without some of the difficulties that Wilson is worried about. And then why the resultant kind of emergence that Thomistic hylomorphism represents kind of fits in an odd place in Wilson's schema and seems like it's strong, but in a strange way. So, at the beginning, Wilson's basic definition of emergence is the coupling of cotemporal material dependence with ontological and causal autonomy. And as Father Thomas said, that's something we see kind of pervasively in the sciences. So you can hardly do chemistry these days without talking about quantum effects. You can hardly do biology without talking about chemical effects. Hardly do psychology without talking about biological effects and causes, etc. It seems like in each case, the higher phenomenon, so to speak, somehow depends on the lower level phenomenon. That if the lower level phenomenon kind of goes wrong or something, that so will the higher level phenomenon. At the same time, so it's not just a dualism or an independence when we go up the pyramid, but at the same time, it's very difficult to reduce higher level phenomena to lower level phenomena. So whereas in the 50s and 60s there was a great push for maybe really it's all just physics down there. Now that's quite a minority opinion, and philosophy of biology and chemistry have kind of come into their own, in addition to a philosophy of mind, and so it's considered quite implausible to think that really we only have the laws of the lower sciences. No, somehow there's genuinely new effects, some kind of autonomy that happens at the higher levels, but that autonomy is coupled with some measure of dependence, and that's just what we mean by emergence. Well, there's also kind of pressure on emergence. And, one kind of pressure on emergence is just what I was just saying, just the idea of like, wait, are these things really autonomous? But Wilson actually gives us a more complicated schema of emergence and the kinds of pressures that emergentist accounts face. So she begins by distinguishing kind of two kinds of emergence. So one is weak emergence and one is strong emergence. And this begins back with the British emergentists of the early 20th century, who distinguished the two, where weak emergence, the higher level, was just not deducible in practice. So basically, you had a really complicated, messy lower level of, say, molecules, and in theory, maybe you should be able to come up with, a biology that was really just chemistry, but in practice, there's just too many molecules doing too many things, and you're going to have to resort some kind of biological constructs like evolution or whatever to make sense of that, and not just be able to do it in terms of chemistry. Though in principle you could. Then on the other hand, there's a view called strong emergence, which says that even in principle, even if you had sort of the biggest computer and knew everything about the lower level state, you would not be able in principle to deduce what was going on at the higher level. That all the chemical facts of the world don't ever give you biology. Then Wilson gives us an account of this in terms of powers, which should be friendly to the Thomist Aristotelian. And weak emergence, actually what we end up with is a subset of the powers at the higher level. So the lower level kind of has all the powers. Chemicals, say, are doing all of the work. There isn't really some separate bit of work for the biological level to be doing. But because the higher level gives us a kind of a compression algorithm, you want to say, it shows it lets us work with just a subset of the powers rather than the full complexity, and that's obviously computationally convenient and makes it easier to talk about. And so you might think of this in physics terms as the reduction of degrees of freedom. um, then the higher level, even though it doesn't have any special new powers, is useful because it kind of gives us a way of talking about things in simpler terms. On the other hand, in strong emergence, we have some kind of genuinely new power at the higher level that's not identical with any power at the low level. It's something radically new. Wilson herself thinks that this is only true in the case of free will, that free will is kind of the only new power in the world that's not physics. But you don't have to agree with her about that. The basic scheme of strong emergence is just the question of when there's some new power that can't be accounted for in any way in terms of the lower level powers, which is why it wouldn't be deducible even in principle. And I would like to line that up with Rob Koons' analysis of two different kinds of hylomorphism. That weak emergence is really parallel to what we might call faint-hearted hylomorphism. So that's this kind of materialist-inflected hylomorphism that we get from kind of the NYU folks like Kit Fine or even Jaworski sometimes, where there's not really any new powers. It's just a kind of a way of describing the structure. Contrast with this, that strong emergence fits with what Rob calls staunch hylomorphism, and particularly in his 2014 account, he's quite explicitly, embracing this idea that the organism or the higher level thing has these new powers, these teleological features that are just not possessed anywhere at the lower level. And so you get a kind of sparse ontology where you have, set out substances that have these new powers, and that gets you a much stronger form of hylomorphism. However, there is a kind of a problem for each of these views in Wilson's account that I'll go into a little bit more in the next slides. But the short pitch is that in weak emergence, the problem is we have this kind of pervasive overdetermination. So we all know that there's some cases where you have to kind of ascribe multiple causes to an event. If we both throw a rock at the window at the same time and the window shatters, and you ask, well, which rock shattered the window? There's no real answer to that, right? They both hit there at the same time. It would both be enough to shatter the window. But we think of that as a kind of an exceptional circumstance, right? That these kind of strange circumstances where you can't pick out a particular cause because of the kind of unique setup of the problem. But we think most of the time, usually, that science is in the business of telling us what the cause of something was, not just giving us a whole stack of causes that are all kind of equally good. And in weak emergence, because there's kind of no new powers at the higher level, the way the higher level acts is going to be a kind of a duplication of the account that we could have given at the lower level. So we're going to have a kind of pervasive overdetermination where there's always going to be higher level causes and lower level causes, which are both an account of the same effects. On the other hand, in strong emergence, because there's some genuinely new power at the higher level, which is changing the physical world, that's going to deny physical causal closure. So now it's not just physics causes that make physics effects, but sometimes some biological cause or neurological cause or rational cause in the mind that leads me to close my hand because I've decided to just now is going to change the physical world in a way that can't be accounted for by any physical cause. And so it seems like physics is somehow incomplete. To complete physics, you need biology and philosophy, which might also seem a bit strange to some people. So just a little bit of tour. So Wilson sets this up as a hexalemma, which means a set of 6 propositions that are all kind of attractive in some way, where you can only have 5 of them. One of them kind of has to go because they're formally contradictory to have all 6. The first idea is dependence, which is just the kind of basic condition that separates emergence from dualism. But there's some way in which the high-level features depend on the lower-level features. These aren't just spirits which have their own workings, but they're unrelated really to the lower level. The next 3 got separated a lot in the mid-century literature, but for our purposes, they usually bundle together, which is really just to say that there's something genuine going on at the higher level. The higher level is real, as is the base features. So physics, chemistry, biology, none of these are describing something that's just fake or that we can get rid of. Efficacy, that there is something genuinely causal going on at each level. These aren't just epiphenomena, but rather we can talk just really about biological causes, chemical causes, and distinctness. So this that a biological cause or a biological feature is not identifiable with any chemical feature. And then we have physical causal closure, which is the principle we just talked about, that every lower level physical effect has a sufficient lower level physical cause. So if you know all the physics now, you can talk to me about all the physics that's going to happen a minute from now without needing to invoke any kind of biology or free will or anything to do that. And then last, that non-overdetermination point, which we just talked about as well, which is that accepting these kind of special cases where we both throw a rock at the window at the same time. And I live in a glass house, as you can see, so in my case that's particularly bad. Effects are not just overdetermined by distinct, individually sufficient cotemporal causes. That we can really talk about the cause of the event, whether that's a physical cause, a biological cause, whatever, rather than just saying, yes, my hand closing has a philosophical cause, a neurological cause, a biological cause, a chemical cause, a physical cause, all of which are equally good explanations. And just depends, which one you happen to want today or something. And then there's the argument for why these kind of come apart. So why you can't have all six at once? Well, the idea is this. We start out by choosing what's S star on this diagram. We choose some special science effect. We just say, here's a phenomenon in biology, say, boom, S star. Pick it at your leisure. Now, by the fact that biological phenomena have, that biology is not causally inert, right? The principle of efficacy, we can pick S. That has some biological cause, whatever that might be, call that S. By dependence, we can say that S star, that biological state, conclusion state, is dependent on P star. Whatever physical state it depends on. Similarly, we can pick P as whatever physical state S depends on. Now, by physical causal closure, we know that P causes P star, because there's got to be some physical cause of P star. It's sufficient and adequate. That's so we can draw that causal line as well from P to P star. And we also know that those two lines are both real. They're both distinct. That's the other premises that we have there. But then it sure seems like we have not only S as the cause of S star, but also P as the cause of S star. Why? Well, because if I change something about P, then I would change P star, right? If I want to intervene on P star, I can intervene on P. But if I change P star, well, S star depends on P star. So I will then have changed S star. So it seems like S star now has two causes, S and P. Well, that's overdetermination, which is just what we said was the sixth item of the hexalemma. So one of these, it seems like you've got to give up. And I want to suggest that these, while Wilson certainly puts them in terms of an issue for contemporary metaphysicians, I think it should be considered quite a painful hexalemma for Aristotelians as well. Why? Well, I think that we too are committed to substance dualism committed to dependence and to realism. Why? Because of Aristotle's doctrine of homogeneous parts. So Aristotle says that the animal moves because of the way its parts push on each other, right? Its muscles push on its bones. But what's a bone according to Aristotle? Well, a bone is a certain ratio of chemical elements. And if it had a different chemical element ratio, he says it would have different properties. It wouldn't be a good bone. It would be too soft or too brittle or whatever. So the kind of thing that you are and how you work depends on the ratio of your chemical elements. So that denies a kind of dualism, right? We're committed to the dependence of the functioning of the organism, the higher level thing, on the proportions of the chemical elements, which are the lower level thing. And similarly, of course, the doctrine of homogeneous parts will also deny eliminativism, right? So we can't get rid of the parts or get rid of the whole in Aristotle. The parts have a role to play, but so does the whole. The whole explains why it moves in the way it does. The movement of the whole animal can only be explained in terms of the purposes of the animal, according to Aristotle, not just in terms of, a bunch of parts moving how they move. The parts don't move kind of autonomously, absent the goals of the animal, so we can't get rid of the animal either. We can't eliminate. Why can't we go with epiphenomenalism? Why can't we just deny efficacy and say that special sciences don't have causal effect? Well, I mean, for Aristotle, science just is the knowledge of causes. And so if there's going to be a biological science, which he certainly thinks there is, that science is going to be the knowledge of biological causes. And so that means that biological or whatever higher level phenomena you're looking at are genuinely causally efficacious. All right, what about denying distinctness? This is the reductionist option, again, was popular kind of in the middle of the 20th century. You just say, well, yes, we can talk about these higher level and lower level differently, different words, but really they're not different in reality. Well, for Aristotle, this falls victim to the doctrine of homonymous parts. So he says, right, if you cut off the hand, it's not really a hand. Somehow the parts of the human being have the whole human being in their definitions. But if that's true, that's kind of the opposite of reductionism, right? Reductionism says that what's really going on is just the parts. We just kind of call them a whole when that's convenient. And Aristotle says, no, in the very definition of the parts comes the form of the whole. The form of the whole cannot be reduced to any of the parts of their functioning. And so we definitely can't be reductionists. We can't deny the distinctness of the whole with the form of the whole from the mere existence of the parts. But also the two, what I want to say, hylomorphic options that have been proposed. So strong emergentism, right, that staunch hylomorphism option that Rob Koons like to discuss, and that non-reductive physicalism, which denies non-overdetermination, that might be the province of the faint-hearted hylomorphists. I think these both fall victim for the Aristotelian to the doctrine of subalternated sciences. So in strong emergentism, right, we deny physical causal closure. We say, no, you just can't know all of physics without knowing biology too, because biological causes will have physical effects that cannot be accounted for by physics on its own. But if that were the case, according to Aristotle, then physics would have to be somehow subalternated to biology. But of course, given dependence back at the beginning, biology has to also be somehow subalternated to physics, right? That somehow we need to know general facts about motion in order for to come to our biological conclusions. So now we're running in a circle, right? We have biology subalternated to physics and physics subalternated to biology. And it seems like we can never get off the ground with our hierarchy of the sciences in Aristotle. And similarly for non-overdetermination, right, the whole idea of the sciences in Aristotle is that each science has its own proper conclusions and phenomena. And so while there is a certain amount of overlap, for instance, precisely because of subalternation, so if physics tells us things about motion in general, those conclusions will also be true in biology, which studies the motion of animals. But the overlap is not total. Precisely what distinguishes the new science is that it, in fact, covers new ground. And so in the case of non-reductive physicalism, which has pervasive overdetermination, there's kind of no new ground. The sciences are kind of wholly subalternated, or you might just say wholly overlapping. And and therefore there would be no new science, according to Aristotle. So I think it's not just the kind of modern metaphysician as a problem here, but the Aristotelian, and by extension the Thomist, since Aquinas, clearly I think wants to be a good Aristotelian about the notion of the sciences, and that comes up all the time, both in his commentaries and he appeals all the time to the Aristotelian structure of the sciences and the theological work. So if we're going to take that seriously, then we need to figure out how we're going to respond as emergentists who grant the basic idea, which Aquinas seems to do as well, following Aristotle, of dependence with autonomy, but without kind of violating Aristotle's strictures on the sciences. So first, just a slight excursus, because it's going to become, I won't bore you too much with the kind of details of Wilson's arguments, but I do want to highlight two little things that we do need to be careful about. The first of these is her formulation of physical causal closure, which has changed a little between 2015, which is when she offers this kind of big review article of her life's work on this, so it's intended to be kind of magisterial, and then 2021, which is her big book on emergence, also intended to be magisterial, but they don't actually have the same account of physical causal closure. In the first one, she just says the lower level physical effect has a purely lower level physically acceptable cause. In the latter one, she says it's a sufficient cause. And I think this is important just at the level of physics, because the latter claim would exclude any kind of stochastic physical laws, right? So any kind of account of quantum mechanics where you have genuine probabilities coming in at the low level, or even the way that certain formulations of relativity without cosmic censorship, or even Newtonian mechanics with Norton's dome, views like that, can have stochastic physical causes. We probably don't want to say that physical effects must have sufficient lower level physical causes. That's kind of committing us to determinism, which is a view that has really nothing to do with the emergence debate in itself. We just want to say, if you have a physical effect that has a purely lower level physically acceptable cause, we don't need to appeal to biology to explain physical effects. Secondly, we need to worry about this question of dependence. So the way that she formulates it in 2015, on the other hand, is a bit odd, because it almost becomes a symmetric relation. She's like, well, the higher thing depends on the lower. When you change the lower, you change the higher. When you change the higher, you change the lower. But that seems to be a symmetric relation, which is an odd account of dependence, which you normally think is asymmetric. In 2021, she kind of cleans that up a little bit. She just says there is some kind of how would I put it? A kind of bearer of the property S, and there's a bearer of the property P, and the property S depends on the property P, when the kind of bearer of the property S depends on the bearer of the property P. So physical or chemical properties will depend on physical properties, just in case the bearers of chemical properties, molecules, depend on the bearers of physical properties, subatomic particles. But in a certain footnote, that gets complicated, because she acknowledges that sometimes you can have a bearer of properties at two different levels. That somehow she thinks this is a kind of trivial case where if the bearer of the lower level property and the bearer of the upper level property are the same bearer, then it's kind of trivially satisfied that S depends on P. That will become important for the Thomistic case as we get into later. All right, so two just little maybe technical points, but they become important for how the Thomist is going to slide into this schema. All right, so now I want to talk about Lonergan a little bit. I'm not sure what your familiarity might be with this important 20th century Thomist, but he serves a useful bridge with taking a lot of very traditional concepts from Thomistic metaphysics and trying to introduce how they connect with 20th century science. So I'm going to borrow from him a bit. To do that, I unfortunately need to introduce a bit of terminology. So first, he has this idea of a conjugate. So a conjugate is a correlative which is defined implicitly by empirically established correlations, functions, laws, theories, and systems. An example is mass in Newton's physics. So you don't directly sense mass. What you sense is a force pushing on you. But when we add up all those forces, basically we posit mass as the way to kind of make simple sense of all the forces and accelerations that we see. So mass is implicitly defined. It's not a kind of extra empirical thing, we wouldn't say. It's part of an empirical theory, but it's not the direct observational term in that theory. What we experience is forces and we see accelerations, and we posit mass as what kind of correctly connects the forces and accelerations that we observe. So that makes mass a kind of pure conjugate, according to Lonergan. So it's going to be anything that kind of fills this role of being defined entirely implicitly by an empirically established system. And that contrasts with what Lonergan calls a thing. And a thing is grounded as an inside the graphs, not relations between data. So mass, again, is the relation between data. This acceleration over here, this acceleration over here. We're positing mass to identify that. But rather, a unity, identity, or whole in data. And not by an abstractive viewpoint, but in the concrete individuality. So the best example is, Fido, our friendly golden retriever here. So Fido is far from being a kind of an abstract term of an empirical system. Fido is what I mean when I refer to the playful puppy, this gently snoring, cozy object by the fire, the thing jumping after the frisbee. It's all Fido. So it's a unity or identity or whole in data. And he wants to stress that, of course, things possess properties. So Fido has a mass. And they are subject to laws, right? Fido is subject to gravity when he leaps for the frisbee. But Fido, the definition of Fido is not from some kind of physical theory, but rather from kind of concrete acquaintance, and seeing the unity or whole that happens in all of these experiences. So you might, if you're a Thomist, just think of the word substance here. Lonergan doesn't use that just because he wants to get rid of certain, he thinks, mistaken views about substance from post-Thomist philosophy. But if you're really a strict Thomist, you can just say substance and you're not going to go wrong. And then last, we have this idea of a scheme, which is a diverging series of positive conditions for an event that kind of go around in a circle. So we might think the event is a golden retriever, playing here at my feet. The events that lead to that are the golden retriever, has a meal for breakfast, gets a lot of energy, and so he's ready to play. But then, the golden retriever is going to get older and less playful. Why does the playfulness recur? Well, turns out I have two golden retrievers, and one's a girl. And so the golden retrievers come together if they've had plenty to eat, and they're healthy, and they make a litter of puppies. And then, given a few years, there's another golden retriever, that's had a nice breakfast and is playing at my feet. So we have the conditions for the event of the golden retriever playing kind of go around in a circle, so to speak, because it's the previous golden retriever kind of playing and being happy that leads to the breeding and the next generation of golden retrievers. So that's a scheme in Lonergan's terminology. Okay, so now why all this terminology? How do we put this to use? Well, this comes into the idea of emergence when we talk about genera here. So the idea is that you have some conjugates, the I's, so something like, say, mass or charge, and those conjugates, the CI's, are born by the things which bear those, the TI's. So you have, say, subatomic particles, and those have a mass and a charge, which are the lower level conjugates. And then maybe at a higher level, you have the TJs, call them, say, the molecules. And those have both I-type conjugates and J-type conjugates. Why? Well, a molecule might have both, will have both physical properties. It will have a mass, say, but it will also have chemical properties, which are not physical properties. So it will have a valence, which is not a physical property. That would be a J conjugate. So the higher level things bear the lower level properties, but the lower level things don't bear the higher level properties. So we have kind of two genera here: a higher level genera and a higher level genus and a lower level genus. And then what does emergence look like? Well, emergence looks like, so we have some lower level things, the TIs. Those have some low level properties. The CIs, when I look at those interacting, they interact in some events. Those events, though, are events in which I can also see the existence of higher level properties. So the events that the subatomic particles are engaging in are events that are also call out for chemical explanations and hence chemical properties, say. And then on the basis of those chemical properties, the CJs, I posit, well, there must be some chemical things to bear those properties, hence the molecules, the TJs. And that's emergence. So just to run through that example a little more slowly. So we have an example of emergence. So we have a standard model of elementary particles. Those are the TIs, the lower level things. And those operate according to some laws and have some properties, charge, mass, etc., which are all implicitly defined. Well, not mass, but exactly, but at least the charges. The other properties are implicitly defined by the standard model, which is that giant differential equation you see on the right there, that implicitly defines all of those properties, those conjugates in their interactions with each other. And then those, given those properties they have, go on to have some interactions, right? So given the standard model, we know that certain interaction patterns can occur, and those we can represent by these diagrams. But when those interaction patterns occur at the right kind of complexity with all the right stuff, then we see, voila, chemical behavior. And when you see that chemical behavior, then you're moved, or Mendeleev was moved to posit the periodic table and chemical objects with atomic numbers, etc. Emergence. Okay. But then we have a kind of metaphysical question we can ask about emergence that Lonergan was quite keen on. So it might seem like, if you have some matter, that matter is just made of atoms. Those atoms are just made of nuclei. Those nuclei are just made of protons and neutrons. And protons and neutrons are just made of quarks. And these things, the little things, are always just actually present there in the big things as a kind of stack up of substantial forms. So this is Avicenna's view that when you combine stuff, you get new substantial forms at the higher level, but the old substantial forms are still there. They just get bossed around. So that's the kind of downward causation or denial of physical causal closure. Lonergan sees a kind of a dilemma here because he says, on the one hand, it seems like Avicenna's view can't be right. After all, we define things as an intelligible unity, gasping to totality of data. So if any datum pertains to a thing, every aspect of the datum pertains to the thing. So no datum can pertain to two or more things. So this is a kind of an argument for unicity of substantial form in Aquinas' terms. And against Avicenna, and against Koons, and against the staunch hylomorphists. And the faint-hearted ones, for that matter, because they also think that the lower level is still present. On the other hand, against the negative answer, the laws of the lower science can be verified in things pertaining to the higher genus. So the laws of physics are still true for molecules. So that makes it seem as if, well, shouldn't the things that bear those properties exist? But he says, no, actually, the latter argument is the weak one. We know it must be the conjugates that exist in the lower level, that still the lower level conjugates must still exist in the higher level. But that doesn't mean that the things do. Why? Well, because for conjugates, abstractive procedures are normal. That's what we said at the beginning. We abstract to get the conjugate. And so there's nothing wrong with noticing that when you abstract, you can abstract at the lower level and the higher level both. But things, the bearers of properties, we do by considering all the data. So that you can't do at two levels at once. So it must be that the higher level thing, the TJ, bears both the CI and the CJ conjugates, and the TI, the lower level thing, kind of goes away. For Thomas, we just call this the doctrine of virtual presence. So why does this look like a kind of oddly strong form of emergence? Well, epistemically, it looks kind of like weak emergence. So I won't run through some of the technical details, but basically, it seems like this should be deducible in principle. So it's what Aristotle says about homoomers by ratio of elements, right? So we know if we know what the ratio of the elements is, we can know the properties of the bone. And in modern science, it means that if you have a good quantum model, you can do chemistry. If you have a good biochemical model, you can do biology, etc. And so that might look like weak emergence, right? You know enough about the lower level conjugates, you know enough about the events, you can predict things at the higher level. That seems like that's weak emergence. On the other hand, we have genuinely new powers. The CJs, the new properties at the higher level, are not identified with any property at the lower level. That's why we have to say CJ and not just another CI. So there's genuinely a new power. That seems like strong emergence. What about the hexalemma? What about dependence? Well, we get that last framework that Wilson gave in the footnote, right? That's what we end up with in the Thomistic picture, because now post-emergence, we have one property bearer, the higher level thing, the organism, say, which bears all of the properties, both the biological ones that exist at the same level, but also, say, the physical properties, the mass, etc., are really borne by the organism as a whole. So yes, the CJs depend on the CIs, but in the kind of trivial sense that they are both born by the same thing, the TJ. What about physical causal closure? No problem here, it turns out. So what happens is that it's just what's merely coincidental at the lower level, which what you can explain at the lower level, but a mere aggregate of kind of coincidences that happen to work in a certain way. You just say, well, I don't know why the chemicals happen to work out that my arm went down. You can put all of the chemical triggers in the neurological cascade there and say, okay, that's why the arm went down. But it doesn't really give you a satisfying explanation. It just seems like a kind of a coincidence that the chemicals happen to work out in that way. Whereas if you give a psychological explanation, it says, well, he put his arm down because he's demonstrating a point, then that gives us a nice compact explanation. And so you get physical causal closure. It's just that the higher level causes become kind of better summaries of the events. So this suggests to me that Thomistic hylomorphism fits into Wilson's schema by kind of denying an auxiliary assumption. It denies her assumption that along with the lower level things, you'll always also, along with the lower level properties, you'll also always have lower level things. So the Thomist denies that. That's the doctrine of unicity of substantial form. And that allows us to actually keep all six of Wilson's hexalemma points. We don't need to be committed to either faint-hearted hylomorphism, where we have pervasive overdetermination, where we have kind of equally good explanations at both levels. No, we say the better explanation is going to be the higher level one. But we also don't need to be committed to breaking physical causal closure, because we can say there is a lower level, perfectly acceptable physical cause. It's just not a good explanation. And so therefore we also don't need to be staunch hylomorphists who think that biology is somehow tinkering around inside physics. Instead, we give up something else. that most people are attached to, which is the idea that there are little bits of atoms inside you, and instead we say, no, we're Thomists. Let's adopt the doctrine of virtual presence. All right, thanks for your time.